Yes, in this class we will discuss another method of nonlinear programming technique, unconstrained optimization. That means there are no constraints given. You will just give a function f of x. It is a unimodal function, that is only one variable will be there. It is also called as single variable function. So the method is called as Fibonacci method. This method is used to find the minimum of a function of one variable. So before going to the method, let us understand what do you mean by Fibonacci numbers. So that is the name of the person. So Fibonacci numbers are given like this. The initial number f0 and f1 they are equal, it is equal to 1. And he has given one relation, or he has given an equation to find the other numbers. By knowing one and first f0 and f1, we can find out the other numbers by using this relation fn. F stands for Fibonacci. So fn is equal to fn minus 1 plus fn minus 2, where n is equal to 2, 3, 4, etc. Suppose if you put n is equal to 2 in this, you will get f2. f2 is equal to n minus 1 is 2 minus 1, that is 1, plus n minus 2 is 2 minus 1, that is 0. So you get f1 plus f0, which is 1 plus 1, 2. So second number is 2, third number is 2. Then if you put n is equal to 3, then you get f3 is equal to f2 plus f1. So like that we have to go. So f2 plus f1, f2 is 2, f1 is 1, so 2 plus 1 is 3. Then if you put n is equal to 4, this becomes f4 is equal to f3 plus f2. So you have to go, we have to reduce 1 1 like that. So f4 plus f3 plus f2 is 3 plus 2. So you can just see here, if you add these two, you are going to get this. If you add these two, you are going to get this. If you add these two, you are going to get this. If you add these two, you are going to get this, like that. So like that, if you proceed, you can get a series of numbers. Those series of numbers, they are called as Fibonacci numbers. So the first number is 1, that is f0. Second number is also 1, that is f1. Third number is 2. Fourth number is 3. Then 5. Then 8. Then 13. Then 21. 34. 55, 89, etc. So by knowing this relation, we can find out this series of numbers. So it is obtained like this. The first number and second number is fixed. If you add these two, you are going to get the third number. If you add these two, you are going to get the fourth number. Then 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 is 21. 13 plus 21 is 34. 21 plus 34 is 55. 34 plus 55 is 89. So 55 plus 89 is 11144, like this. So you get a series of numbers. These numbers are called as Fibonacci numbers. Now let us see how we can solve a problem of nonlinear programming using these numbers. So the problem will be given like this. There is no constraints in this problem. Simply they will give find the minimum value of the function f of x. F of x is given like this: x power 4 minus 14x cube plus 60x square minus 70x in the interval 0 to 2. So the one important thing is, in the Fibonacci method, he has to give the interval. That means in which interval that minimum value lies, and he will also give the value of n. So up to how many n we have to take. So here the meaning of that is, we have to find out the minimum value of the function f of x, which is given by this, but in the range 0 to 2. So that will lie between 0 and 2. Somewhere here, if you take the function something like this, if you have a global minimum, local minimum, I have expected on the day. So somewhere here, you may expect your maximum minimum value. So that value you have to find out. That's all. So depending on the function, the graph will be there. Now, for first step, what we are going to do is we are going to find out a initial approximation number, which is denoted as n2 star, which is given by fn minus 2 by fn into n0. N0 is this difference in the interval. That means in range. You can call it as range. So highest value is 2, lowest value is 0. So your x value lies between 0 and 2. Therefore your L naught is 2 minus 0, that is 2 only. So L naught is 2, whereas since n is 6, this becomes 6 minus 4, that is F4. F4 by F6 into L naught becomes F4, you know, it is 5. F6 is 13. So 5 by 13 into 2, which gives 0.47619. So this is the initial approximation for the value of x. So this we are going to take it as x1. So whatever n to start we are going to have, this itself is taken as x1, which is called as the initial approximation. Now once you get x1, the another value x2 is found out by subtracting this x1 from the higher value, that is from the last value, that is 2 minus x1 is x2. So 2 minus x1 is x2. Or in other words, x1 plus x2 is equal to 2. That is meaning. So if you do that, 2 minus x1, 2 minus 0.47619 is 1.52381. So now we got two values of x. That is, one is x1 and another is x2. So suppose if they give 3 here, you have to take 3 minus 0.47619, it becomes 2.52 something. Right. Now, after getting these two values of x1 and x2, we have to get the values of the function at these two values of x. That means x1 is this much, x2 is this much. We are going to find out f of x1 and f of x2. By putting the value of x is equal to 0.47619 in this, we are going to get f of x1. Similarly, by putting the value of x as 1.52381 in the same expression, you are going to get f of x2. Now compare these two values. Among these two values, which is minimum to mark? So here, both are negative, but this is minimum. So if the value is negative, what happens? The higher magnitude is the minimum value. So here we can see that f of x1 is less than f of x2. That means the meaning of that is, I have drawn a figure here. You can see this is y-axis is f of x, x-axis is x. X is x-axis, f of x is y-axis. Now we have got two values of x1 and x2. The range is 0 to 2. 0 to 2 is the range. One value of x is x1, which is 0.47. Somewhere it will come here. Another value of x is x2, 1.52381, which is somewhere here. Okay, approximately I have plotted this. Now I have written the values of f of x here. At x is equal to x1, f of x is minus 21.188, that I have shown here. And at x is equal to x2, that is 1.52381, f of x value is minus 11.49. So those two values I have written here. So now this is minimum value that compared to this, correct? So minimum value I have got here. Now what happens once you get f of x1 less than f of x2? Now among these, now what we are doing is we are reducing the range now. We have to find an approximate value of x at which f of x is minimum. That's what. At what value of x, f of x is minimum, that we are finding. So the broad range is 0 to 2. Somewhere in between 0 and 2, you have got your minimum value of f of x. To find that, what we are doing is now the range is 0 to 2. From the 0 to 2, since we have got both negative values here, this can be omitted now. That can be omitted. So we can assume that value of x for which f of x is minimum lies between these two things, 0 and x2. That means this x2 comma 2, this is the range, this is x2 comma 2, like this we are going to write, x2 comma 2. This can be deleted, that can be omitted. Now we are fixing the range only from here to here. Okay. Now that is what I have done here. x2 comma 2 is deleted. Now I am going to find out one more value of x. Now what I am doing is I am finding the approximate value of x for which f of x is minimum. The another value of x is found out like this. I am going to take it as x3. x3 is equal to 0, initial value is 0, plus x2 minus x1. I will take the difference between these two. That means I am going to assume the value, third next value of x in between these two. So the approximation is 0 plus x2, 0 is this value, plus x2 minus x1. So what is that value? x2 is this much, 1.52381, minus x1 is 0.47619. If you subtract, you are going to get 1.04762. That is your x3 value. So that lies somewhere here. x3 will come somewhere here. Okay. Now, at this value of x, you find out once again f of x. That is f of x3 we are finding by putting x is equal to 1.04762 in this given function. We can get your f of x3. Now you compare this f of x3 which is f of x1. F of x1. Okay. So already we got f of x1 as less than f of x2. So f of x3 is gone now. Now remaining is f of x1. Now I will compare this f of x3 with f of x1, which is less. Actually this is less. If you compare f of x1, which is 21.188 negative, compare with minus 22.375, this is less than this. That's what I have written here. F of x3 is less than f of x1. So then what I can do here is f of x3, you are getting x3 here now. x3 value you are getting here. So your x2 value is coming somewhere here. x3 value is lying between now x1 and x4, correct? So somewhere there we have shown here. Here we have shown. See here, this is x1, this is x2. x3 will be somewhere here, and its value is minus 22.375, which is greater than this value. Greater than this value. Sorry, less than this value. Since it is negative, you know. So this is less than this value. Now, which one I have to delete now? Now I can delete this one now. This I can delete because it may lie in between these two. So what is this into one? x3 comma x2. Correct. x3 comma x2 can be deleted. Now what I am doing is I am removing that range. I am reducing that range. So first I have deleted this. Then I am deleting this x3 x2. Okay. This I am deleting. That's what I have done here. x3 x2 is deleted. Now I am going to get the next value x4. x4 is now 0 plus, now it may lie in between these two. These two means x3 minus x1. So 0 plus x3 minus x1. x3 is this. How much? 1.04762 minus x1 is, we have got 0.47619. If you subtract, you are going to get this value. That is your x4 value, next value. So find out f of x4 using the same function. Put x is equal to 0.57143 here and simplify. You will get f of x4 as minus 22.914. Now you compare this f of x4 value with f of x3 value. Now what? First initially f of x1 was minimum. Then we got f of x3 as minimum. Now if you compare, f of x4 is becoming minimum. Getting? So f of x4 is slightly variation. Minus 22.914, this is minus 22.375. But even then, this is minimum value. Now, if I take that, then what happens? That value itself can be taken as the minimum value. Otherwise, you can still do one more thing. 0 x4 can be omitted now. So let us omit these two now. This I can omit. So there is no chance of getting there is no chance of getting in between 0 and x4. Therefore, 0 x4 is deleted. So there is a chance of getting the value of x in between only x3 and x4. Only in between those two you can get. That is the possibility. So the next approximation is 0 plus x3 minus x4. If you do that, you are going to get a value which is equal to x1 itself. If you subtract that, you are going to get a value which is equal to x1 itself. So your x5 will become equal to x1. So that means your f of x5 is nothing but your f of x1 itself. Correct? Both are same. So once you get the same value, now if you compare, now we have got the answer. F of x4 is less than f of x3, and also f of x4 is less than f of x5. It is less than both the values. That means this itself is the minimum value. F of x4 is the minimum value, and at what value of x? When x is equal to 0.57143, that is at this value of x, you are going to get the minimum value of f of x. So we can stop at this stage. So some 4 iterations, 4 steps or 5 steps we have to do, and we have to learn. So this is what is called as the Fibonacci method of non-linear optimization technique without any constraints. Now if you want, you can check this. How to check this, I will tell you. F of x value is given. So I will take this f of x value as y. What is the x power 4 minus 14 x cube plus 60x square minus 70x. Okay. Now what is the necessary condition for a function to be minimum? First derivative should be 0. Correct? Necessary condition is dy by dx should be equal to 0. If you differentiate this, what you will get? 4x cube minus 42x square plus 120x minus 70 is equal to 0. Correct? Now you have to solve this. If you solve this, you will get 3 values of x. Using calculator, if you solve, you will get 3 values of x. Out of those 3 values, one value will be this. What is that? This. This will be one value. So if you solve that, and at those values of x, if you find out the second derivative, d square by dx in there, if d square by dx square is positive, that is greater than 0, then we have the minimum value. That you can check. Not necessary, but if that is for your reference. So you will get 3 values of x by solving this. 3 values of x. At each value of x, you find out the value of second derivative. You once again you differentiate this. You will get d square y by dx square. What is that? You are going to get 12x square minus 84x plus 120. Okay. So in this expression, you have to put those 3 values of x. So one value will be this. You may not get exact value, you may get 0.571, something like that. So just put that value here. If this value becomes positive, then it is the minimum value of the function. But the value of x should lie between 0 and 2. That is important. Only those values you have to take. Okay, because it has given the range. If you get any value of x not in that range, if the value is 3 point something or 4 point something, that value you should not consider. Okay, because it has given the range here. So in Fibonacci method, he will give the range. In that range, you are approximating the value of x. You are using this Fibonacci numbers. So they will give the value of n. Suppose if they give n is equal to 7, here you have to take f5 by f7. Okay, n minus 2 means f5 divided by fn means 7. f5 is this. Then the ratio becomes 8 divided by 21 into 2. So this 2 will remain same because that 2 is nothing but your range. 2 minus 0, that is your L0, initial value of x. Initial value of x is taken like this. Later on, that range is getting reduced by finding the values of the function at those modified values of x. So whichever is minimum, that value we are going to take at the end. And for checking that whether we have done correctly or not, we have for that function we are going to take both dy by dx and d square by dx square, and we are equating dy by dx to 0, and we are solving that using the calculator. Whether you may get quadratic equation or cubic equation. Here you have got cubic equation because x power 4 is there. Get the corresponding values of x. At those values of x, get the second derivative values. If second derivative value is positive, then you are having the minimum value of the function. Okay, that is it. So only to find the minimum value of the function, this Fibonacci method is used. Okay.